Hello everyone. Welcome to this complete lecture on Amplifier in Electronic Engineering. In today's video, we will understand what is an amplifier, why amplification is needed, types of amplifiers, amplifier classes, important parameters, working principle, applications, advantages, and limitations. If you are an engineering student, diploma student, or electronics beginner, this lecture will help you build strong fundamentals. So let's get started. Explanation. The topic is Amplifier in Electronic Engineering, Understanding Signal Amplification and Applications. Amplifiers are one of the most important building blocks in electronics. Without amplifiers, communication systems, audio systems, and industrial electronics would not work properly. Introduction. First, let us understand what an amplifier is. An amplifier is an electronic device that increases the amplitude of a signal, converts weak signals into strong signals, uses an external power source, maintains the original waveform shape. This means the amplifier makes the signal bigger, but ideally it does not change the shape of the signal. For example, if the input is a sine wave, the output is also a sine wave, just larger. Amplifiers are used in audio systems, communication systems, instrumentation, industrial electronics. Why amplification is needed? Now the question is, why do we need amplification? In real-world electronics, most signals are very weak. For example, microphone signals are in millivolts. Antenna signals are extremely small. Sensor outputs are also very low. If we directly connect these signals to speakers or processors, speakers will not produce sound. Signals cannot be processed properly. Communication systems will fail. So we use an amplifier. The amplifier increases the signal strength to a usable level. It makes weak signals strong. It enables further processing. It allows proper functioning of electronic system. Basic amplifier block diagram. The basic amplifier block diagram is simple. Input signal amplifier circuit, output signal. Now let's understand the main components. 1 keycap active device. Transistor. Operational amplifier. This is the heart of the amplifier. 2 keycap power supply. Provides energy for amplification. 3 keycap biasing circuit. Sets the correct operating point of the transistor. 4 keycap load. The device connected at output like a speaker. The input signal controls the active device. The power supply provides energy. The output becomes a larger version of the input. Types of amplifiers. Amplifiers are classified in different ways. Based on signal type. Voltage amplifier increases voltage. Current amplifier increases current. Power amplifier increases power. Power amplifiers are used to drive speakers. Based on frequency. Audio amplifier 20 Hz to 20 kHz. RF amplifier radio frequency range. If amplifier intermediate frequency in communication systems. Based on configuration. For BJT. CE common emitter. CB common base. CC common collector. For MOSFET. CAs common source. CG common gate. CD common drain. Each configuration has different gain and impedance characteristics. Classification based on classes. Amplifiers are also divided into classes. Class A. Class B, Class AB, Class C, Class D. Each class differs in efficiency, distortion, power consumption. For example, Class A low distortion but low efficiency. Class B higher efficiency but more distortion. Class AB balanced performance. Class D very high efficiency, switching type amplifier. Different applications require different amplifier classes. Important amplifier parameters. Now let's discuss important parameters. 1 keycap voltage gain, AV. 2 keycap current gain, AI. 3 keycap power gain, AP. 4 keycap bandwidth. 5 keycap efficiency. 6 keycap input impedance. 7 keycap output impedance. Voltage gain formula. Voltage gain is equal to output voltage input voltage. If output is 20 V and input is 2 V, gain is equal to 10. Bandwidth tells us the frequency range over which the amplifier works properly. Efficiency tells us how much input power is converted to useful output power. Working principle. The amplifier uses transistor or op-amp as active device. External power supply. Here is the key concept. A small input signal controls a large output signal. Very important point. An amplifier does not create energy. It only controls energy from the power supply. You can imagine it like a valve. A small control signal allows large energy to flow from the supply. That is amplification. Applications in electronic engineering. Amplifiers are used in many fields. Audio systems, public address systems, radio transmitters, television receivers, biomedical instruments, industrial automation. In ECG machines, amplifiers increase tiny heart signals. In communication systems, amplifiers strengthen transmitted signals. In factories, amplifiers process sensor data. Amplifiers are everywhere. Advantages. Advantages of amplifiers. Increase signal strength. Enable long-distance communication. Improve signal processing. Essential for electronic systems. Modern electronics cannot function without amplifiers. Limitations. However, amplifiers also have limitations. Noise amplification, distortion, power loss, heat generation. Proper design reduces these issues. Engineers must balance efficiency and signal quality. If you found this lecture helpful, please like, share, and subscribe for more electronics tutorials. Thank you for watching.